channel, welcome back to my channel.
Hello.
If you are new, Rowan is here. It is day 11. Happy 24 days of science experiments with Erica and Rowan.
Would you like to reveal this one to people while I open the box?
It's so appropriate because I have so much of this. Magnetism.
That's why I can't get away.
That's right. All right, today we're talking about magnetism and not that kind. You can move a little closer to me. I think you're not quite as in the shot. There we go. All right, what's in the box?
In the box we have two small wheels. Two small dark coloured
Magnety wheels. And it does tell us we additionally need some adhesive tape.
Oh, adhesive tape.
There it is. I'm wearing my glasses today so that I look smarter.
Yeah, you look very smart.
Thank you.
And especially in the hat.
Yes. Experiment 1. Take one ring magnet in each hand and move them towards each other. If you happen to approach the north pole of one magnet with the south pole of another magnet, the magnets will be pulled backwards and stick together. Will be pulled towards each other and stick together. This is because opposite poles attract each other. However, if two north poles or south poles meet, they can repel each other. In this case, it is not possible to press the magnets together.
Are they doing that?
Yeah.
They might be a little far from the camera for that to be enjoyable.
That might be. There, they're gonna magnet together. Ooh, together. Yeah. Here, I'm gonna try to push them together and they're not gonna. Oh, they only wanna go.
They look like they're surprisingly strong for their,
They are.
for their size. I just got the piece of paper because I thought it might be a little easier to see them.
Absolutely.
If we're doing close-up stuff.
Yeah, great call.
Alright, so experiment 1 was
That was
playing
experiment 1, playing with magnets. Number 2, place a ring magnet standing on its edge on a table and roll a second one towards it. Find out how near you can get to the magnet before it starts to roll away. Then try to let the magnet on the table roll as far as possible by steering it with the magnet. Okay. Whoa!
I think you don't need to roll the second one then.
I didn't mean to. Whoa. That's just magnetism.
Okay, so
roll.
I got challenge 1 for me is just to sit on the page.
Ah!
Oh, see that? Turn around. I'm trying to make it roll away.
Yeah,
but
try to
just
make it
spun
roll
around.
away by steering it with the magnet. Oh. Did you see that, guys? Oh.
Let's try that again.
This is really fun. I'm enjoying this.
I get it to roll without running away is the challenge.
That's super fun.
Wow, alright, let's experiment 2. Very cool.
Now, experiment 3 is tie a thread. Approximately 1 foot to each of the ring magnets.
Let's snip this in 2.
Okay.
So I've got 2 bits of thread. We're going to just put the thread through here. We're just going to hang it along the...
We're just going to tie a thread to each ring magnet. Tape the ends of both threads to a table 4 inches apart and suspend them so that they can freely move.
What do you mean tie them to the table?
Tape the ends to the table. So like, we'll tape it like this. Oh, look, we'll drop it. I'll drop mine.
Yeah.
And we're gonna watch how they move. So perhaps we should do it from your side because the sun is over there, the brightness.
So should we hold them?
Yeah, here, we can just hold them.
You can just hold them, yeah.
Okay, and then we're gonna dangle them down this table and watch what happens.
Oh, I see.
Oh!
Oh, yeah.
Woo!
So they clearly want to stick together.
They do! Woo!
They definitely want to stick together, don't they?
They are, yeah. These are really great magnets.
If you hold them up, Erica, and just pull them apart very, very slowly, can you get them to hover near each other? So their magnetism is not quite supporting their weight
No.
there.
I can get
But
them to do that.
I bet if
Look at that.
yeah, that's
Kind of what you were thinking
kind
of.
of what I was going for. But could you get them to pull apart slightly?
Maybe, I need a little bit of a closer grip.
But I think not sure where in my life I got this from, but I have the idea that magnetism is exponential. So if they're a little bit apart, then they still magnet each other. But if they're twice as far apart, then they have half the magnetism. So how much they magnet each other gets exponentially less the further apart they are. So you can put them, let's see how far apart they have to be before they'll come together, before they'll affect each other. So they're comfortably sitting there, and just the friction of the table is sufficient to stop them from going anywhere. Let's just inch them together. See how long it takes.
Oh,
So about the width of themselves.
yeah.
So that's yeah.
Yeah, that's a fun extra one.
There we go.
Yeah, eventually they attract each other. So,
What else we got in there, Erica?
what a great time. Well, it just wants to talk about magnets. Magnetism is a natural phenomenon. Every magnet has two poles. The North Pole and the South Pole are connected by invisible magnet lines, forming the magnetic field. At the poles, the attractive force is strongest. Yeah. Earth also has a magnetic field, and thus is a giant magnet. Did you know Earth is a giant magnet?
I did not know that. Well, actually, I did, because that's what the auroras are, aren't they? The aurora borealis and the aurora australis. They are Earth's magnetic field deflecting harmful radiation.
Really?
That's what the light is.
Huh, I had no idea.
So our magnetic field actually protects us from a lot of dangerous rays from the sun.
What a nice magnetic field it is.
Yeah, so you should
It
definitely, every
also-
time you see the aurora, you should thank the aurora.
Yeah, and you should be grateful because not a lot of people get to see that. The Earth's magnetic field helps birds, dolphins, and whales find their way on long voyages or flights. They attract iron and a few other metals. Permanent magnets are made from steel or ceramic. They can, like in compasses, microphones, or electrical measuring devices. I had a hard time with that word. But electromagnets are only magnetic while a current is running through them.
Let's have a look at this cool picture. Tell us about this one.
This is an electromagnet. When a current runs through a wired coil, a magnetic field builds up and an iron object within the coil enhances the field and results in a magnetic force.
It's interesting, and none of that's included for this experiment. However, I wanted to try it out, so
Oh my God.
I got some things. Now, this is going to be a great little edit point, Erica. If this goes horribly wrong, this is the point at which you just cut to us going, "See you later."
All right, here we go.
Guys, all right.
Thank you so much for joining us here today for day 11.
That's really fun.
It was a great time, fun with magnets. Please give us a like, a subscribe, hit that little bell notification so that you get a reminder anytime I make a video. And we will see you tomorrow.
See you tomorrow.
Happy December!